Let's graph a secant function. We want to graph y equals 2 secant 1/2 x. The first thing to note, or a simple thing to do with a secant function, is to remember that it's the reciprocal of the cosine. So I'm going to start by thinking about the graph of y equal to cosine 1/2 x. Now cosine's period is 2 pi if the coefficient of x is 1. This particular cosine is going to have period 2 pi divided by 1/2, which is 4 pi. So keeping that in mind, I'll scale my axes. So let's draw ourselves some axes to use. There's an x and a y-axis. And I'm going to think about scaling or drawing two periods of this. So I'm going to think about 4 pi and negative 4 pi. And start with those on your axes and then have them to get 2 pi and negative 2 pi and so forth. So just putting in some tick marks to work with for a moment. Maybe I will label these negative 2 pi and 2 pi. I'm going to start by drawing this cosine function with a dashed line. Now its amplitude is 2. That's this value right here. And so scaling the y-axis, remember that the cosine starts at 2 on the y-axis, and this particular one's going to finish at 2 at 4 pi and then be at negative 2 at 2 pi. And so here's part or one period of that with a dashed line. That's part of the cosine, and then I'm going to do that again in the negative direction, so using similar points. I'll draw another dashed piece of the cosine. And now we can think about the secant. Now the secant is the reciprocal of the cosine, so where the cosine is 0 is going to be a vertical asymptote for the secant. Having drawn the cosine, I can see the zeros and I can come up with, or use them to draw, my vertical asymptotes. So there's a vertical asymptote, there's a vertical asymptote for the secant, I mean. Here's another vertical asymptote, and one more in the two periods that I'm getting ready to draw. Those are vertical asymptotes. Now the secant is the reciprocal of the cosine, so a piece of the secant is drawn in between this pair of vertical asymptotes, and then repeating that idea, here's a piece of the secant, and then for this final little bit to the right, I have a piece of the secant. And keep in mind the black solid curves are the actual graph that I was trying to draw. And there's a graph of the secant, two periods. Now's a good time to check a graph on a graphing calculator. Let's check the one we just did. So we'll go to our graphing calculator, we'll go to y equals, and I want to enter 2 secant of 1/2 x. Now there's no secant button, so what I enter is 2 divided by the cosine. Now I want to put in 1/2, so parentheses 1 divided by 2, close parentheses, then x, then close for the cosine. There are vertical asymptotes involved, so let's check our mode. And in mode, I've made sure I'm set in radians and dotted, so the calculator won't try to draw this with one continuous line. Then think about a window. And what I've set is this negative 12.566. That's negative 4 pi. And if you recall the graph we did, we graphed from negative 4 pi to positive 4 pi. I left my x scale at 1. Let's set our x scale to pi divided by 4. So we see tick marks at those units. I've got my y min set to negative 6 and y max to 6. And if we don't like that, we can always change the window. But let's take a look at the graph. And you'll see that that matches very nicely what we had graphed a few minutes ago. Let's graph a cosecant function. We want to graph y equals 3/2 cosecant of x minus pi over 2. One thing to do with the cosecant is to remember that it's the reciprocal of the sine. And so we're going to start by analyzing 3/2 sine x minus pi over 2. The coefficient of x is 1, so the period's going to be 2 pi. The amplitude's 3/2. This pi over 2 is going to create a horizontal shift of pi over 2 units. to the right. So let's start by drawing some axes to work with and scaling our axes accordingly. Here's our y-axis and x-axis. Now, if the sine did not have a phase shift, its period would be 2 pi, and I'd locate 2 pi on my axes, and then here's negative 2 pi, somewhere over here, the same distance from the origin. And halfway between 0 and 2 pi is pi, and negative pi to the left. And then if I put some more tick marks, each of these are pi over 2 units apart. So let me go ahead and label pi and negative pi and put additional tick marks to the left. And then what I'm going to do is I'm going to graph the sine with an amplitude of 3/2 shifted pi over 2 to the right. So I probably ought to scale my y-axis in single units. And then with orange, I'm going to graph the sine with the dashed line, because in the end I want to graph the cosecant. But if I shift from 0 pi over 2 to the right, I'm at pi over 2. Then I need to finish my graph, putting a tick mark here on the axis, because this is a sine graph, and at the center of one period I want to be on the axis. And so here's my amplitude of 3/2, and then using that I go down to negative 3/2. And here's one period of that phase shifted sine. Now I want to do that again, but where I would have been at negative 2 pi with the phase shift, I'm here, and then I'm on the axis, and I finish at this point. My amplitude is 3/2, so using that, I need to draw another dashed, not supposed to be dashed, piece of this sine wave. And now I'm ready to think about the cosecant. Remember, the cosecant and sine are reciprocals, and the cosecant is 1 over the sine. So where the sine is 0, which is clearly indicated by drawing the sine, are vertical asymptotes for the cosecant. So I'm drawing the vertical asymptotes for the cosecant at values where the sine is 0. And I've involved the 3/2 in my graph of my sine, so I'm ready to draw the pieces that make up the cosecant graph. And so these solid black curves are the pieces of my cosecant graph, using the sine to get to this point. And so there's a sketch by hand of that cosecant graph. Now what we want to do is check that graph using a graphing calculator. So let's do that. Going to our calculator, we're going to go to y equals. We can't enter the cosecant because there isn't a cosecant button unless we enter a reciprocal. So we're going to enter 3/2, and I'll put that 3 divided by 2 in parentheses, divided by the sine of x minus pi divided by 2. And that's the same as 3/2 cosecant, sine of x minus pi over 2. Check your mode to make sure you're in radians and dotted so the calculator doesn't try to draw this connected. Take a look at the window, and what I've set as a window is this negative 4.7. If I enter negative 3 second pi divided by 2, and move to the next value on the screen, you can see that what I've entered is negative 3 pi over 2, positive 3 pi over 2. As my scale, I have pi divided by 2, and it is this 0.78 decimal, and so forth. So let's take a look at the graph. And what we see is the graph of 3/2 cosecant x minus pi over 2.
Determine an equation for the graph. Well, when we look at this graph, with the asymptotes at 0, 2 pi, and 4 pi, it makes us think of the cosecant graph. But notice that it's been stretched horizontally, because normally the period that is a complete cycle would occur in 2 pi, but this is 4 pi. That means it's been stretched horizontally, and that means our value for b would have to be 1/2. And so the equation that we're looking at would be y equals the cosecant of 1/2 x. Let's look at another example in which we find the equation for a graph. Determine an equation for the graph. When we look at this graph, because of where the asymptotes are, we think of this as probably the secant graph. But it's also been translated up 1 unit because you can see here it's going through or touching the x-axis when normally it would have been down here at -1. And this one, of course, instead of going through 0, 1, it's going through 0, 2. So we've translated it up 1 unit. And so that means it's simply y equals 1 plus secant of x.